So, over a year, the separation of the star decreases by a yard in an orbit that is 435,000 miles in diameter, which is precisely the number that can be calculated from Einstein's equations. In fact, the two stars will completely collapse in about 240 million years owing to the loss of gravity waves, because this energy is being lost constantly by the system. This precision experiment can be reinterpreted as a way in which to test the accuracy of general theory of relativity by Einstein, and the numbers are so precise that we can conclude that general relativity is 99.7% accurate. So because we touched upon these neutron stars, I thought that I will give you also an introduction. I will use this opportunity to give you an introduction on neutron stars and other stellar remnants as we proceed. That's why I pulled out this other book, which is a very important, this is Foundations of Astrophysics. This is a very basic, very staple textbook when you are learning astrophysics as an undergrad. I believe this is used as an undergrad classes. I could be wrong. It might be an introduction book for even grad students, but overall it's a very good book, as the author has noted. So I think because these topics are so relevant, and I think because these topics are such interesting and good topics, we can even reference this book. So I am going to chapter 18, page 409. Yes, stellar remnants. The life history of a star is determined primarily by its mass, okay? If you know a star's initial mass, you know, at least in broad outline, how it will evolve. So the mass of the star is extremely important, extremely important. Pretty much, astronomers don't have a lot to go by in their lab, which is the night sky and the heavenly bodies. They're very far away. So something like mass, something basic, something that you can find a way to measure, is really all you have at hand. So mass is very, very important. And thankfully, mass is also something we can observe. Other factors, or figure out from observation. Other factors like the star's initial chemical composition and initial angular momentum have a smaller effect. So there are things like the initial chemical composition of a star, as well as initial angular momentum, but those have a smaller effect. For instance, the fusion history of a star depends on its initial mass. All mass limits below are approximate. So the statement, a star's properties are determined primarily by its mass, is known as the Russell-Vogt theorem, after the ubiquitous Henry Norris Russell and the German astronomer Heinrich Vogt, who were the first to realize its truth. So depending on the star's mass, there's going to be different fusion type of things that happen, and we will get into that in just a minute. I actually need to get a coffee, but lots of good things are coming, because we will get into what a white dwarf is. We will get into mass radius relationship of a star. We will also get into neutron stars and pulsars. And we will get into black holes, of course, because why not? Bye, bye, beep, 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 beep. This one is our Baji. Baji, are you listening? We must understand supernova remnants today. So we will, over the course of probably this live session and the next, we will cover this. Ooh, and nova and supernova. Ah, I'm so happy. Type 1 supernova, type 2 supernova. Oh, this is like my childhood coming alive. Yay. Baji, are you kicking me? Oh my gosh, look at this. Look at Baji's giving me a kick. Hi. Here, let me rotate this.